There is an interesting story about Ramsey numbers. In the 1950s, the Hungarian sociologist Lloyd was studying friendship between children. And he observed that in any group of 20 children, there is a group of 4 children which are either all friends or not friends. So he checked many groups of 20 children, and he observed that he can always find a group of 4 children, such that they all are friends or there is no pair of friends between them. Luckily, he knew the famous Hungarian mathematicians Erdős, Turan and Sos, who are very well known in Ramsey Theory. And they said that actually this is a simple result in Ramsey Theory, which says that, yeah, in every group of 18 or more people, you can find either a four-colleague or an independent set of size 4, which in the language of friendship graphs means that there is a group of size 4 which are all friends or which are not friends. Well, it's time to formally define Ramsey numbers. So for 2 integers k and l, the Ramsey number r of k and l is the minimum number such that every graph with at least that many vertices must either contain a clique of size k or an independent set of size l. So every graph with at least that many vertices must have either one or the other. For example, we know that r of 3, 3 is 6. Indeed, we saw a graph on 5 vertices which doesn't contain a clique nor an independent set of size 3. But we just proved that every graph on 6 vertices must contain either of them. It is also known that r of 4 and 4 is 18, which is exactly the reason why in every group of 18 and more people there are either 4 friends or 4 strangers. But even r55 is not known. We know that it's at least 43 and it's at most 48. And it's a big open problem in mathematics to find the exact value of r5 and 5.